Now on to interpreting the R-square in multiple regression. It is almost the same calculation as in bivariate regression. The only difference is that now we have multiple independent variables in our model. Recall that an R-square of 1 means that our model perfectly estimates our dependent variable, and R-square of 0 means our models cannot estimate our dependent variable at all. Now I'm going to show you how to interpret the R-square in multiple regression. Suppose our R-square was 0.12. We move the decimal place over to the right twice and turn it into a percentage. So in this case, we move the decimal place over to the right twice and get 12%. Then we would say that variations in all of our independent variables explain R-square variation in our dependent variable. Or in this case, from our example, we would say variation in GNP and variation in conflict explains 12% of the variation in military spending. The adjusted R-square in multiple regression is also similar to the adjusted R-square in bivariate regression. Recall that the adjusted R-square takes into account the sample size and the number of independent variables. Now I'm going to show you how to interpret the adjusted R-square in multiple regression. Suppose our adjusted R-squared was 0.11. We move the decimal place over to the right twice and turn it into a percentage. So in this case, we move the decimal place over twice and get 11%. Then we would say that after taking into account sample size and the number of independent variables, variation in all of our independent variables explains adjusted R-squared percentage variation in the dependent variable. Or in this case, we would say after taking into account sample size and the number of independent variables, variation in GNP and variation in conflict explains 11% of the variation in military spending. Now I'm going to show you how to calculate estimates in multiple regression. When you calculate estimates, you make predictions of the dependent variable. The first step in doing this is writing out your entire regression equation. Dependent variable hat equals b hat 1 times the first independent variable plus b hat 2 times the second independent variable plus a hat. Then you choose values for your independent variable that you will insert into your equation. When you insert values into the equation for your independent variables, this is known as holding them constant. You should make sure the values you choose for your independent variables make sense given your data. For example, often we want to know what the estimate of the dependent variable is when all the independent variables are at their means. So we calculate the means of the independent variables and insert them into the equation. We could also make estimates for when the independent variables are at their minimums or at their maximums. However, we should never make estimates for values of the independent variable that are outside the bounds of the data we have for our variables. So for example, if the maximum value for our independent variable was 10, we would not make estimates for when our variable had a value of 11. After you make the estimates, you interpret the results. To do so, you would note the values of the independent variables and the value of the estimate. So as an example, I will use the regression equation from earlier in the lecture. I wrote down the regression equation. Military spending hat equals 335.40 times GNP minus 567,163.63 times conflict plus 576,886.56. Now let's say the mean of GNP was 8375.80 and conflict was at 1, meaning a country is in conflict. I inserted these values into the equation here and here. Military spending hat equals 335.40 times 8375.80 minus 567,163.63 times 1 plus 576,886.56, which equals 2,818,966.25. To interpret this information, you would say when a country has an average GNP and is involved in a conflict, it allocates $2,818,966.25 to military spending.